video looks at hyperbolic integration. You'll see that the rules of hyperbolic integration are given in your notes. We have the two basics. We then have the inverse hyperbolics, and then the integration for tangent. So let's have a look at example 1, where we're being asked to integrate cosh. You'll see that we've got a 4x minus 1 sitting inside the function, so it is a chain rule in reverse. Cosh integrates to shine, or 4x minus 1, and I divide by the differential of the bracket. So using my formula book to remind me of the results and applying my chain rule backwards, I come up with the result that we've got here. So that's a nice straightforward one. These integrations will be used using all the techniques that you learnt in your A2 maths. So you might get integration by parts, integration by substitution, etc., with hyperbolic functions included. So that's a hyperbolic one. I suggest you have a look at the examples in your textbook, which will give you further illustrations of the integration techniques. So that's examples 24 to 27. Now let's have a look at number 2 together. This one is using the rules for inverse hyperbolic integration. So, little reminder of the techniques that we met when we were doing the integration of inverse trig functions. We need to write our fractions in a format that's going to match our standard rules in the formula book. This one here has a 3 times the x squared, so it's not yet in the required format. Let's have a quick look at the formula book. We are looking to find all of these that matches our question. This one here is the closest because it has an x squared term, take away a constant that's squared. So we need to rearrange our question to be similar to this. So that means that we need to factorise the 3 that we've got sitting in front of the x squared. So our question becomes square root of 3 brackets x squared minus 16 dx. The 1 over root 3 I can take out the front of the integration sign. And now I have an integration in the required format. So we have x squared minus 4 squared dx. I can now use my standard result from the formula book. So integrating, I get 1 over root 3 inverse hyperbolic cos of x over 4. And I need to now apply my limits of 5 and 4. So the question now becomes 1 over root 3 r cosh 5 over 4 minus r cosh 4 over 4, or 1. we have two inverse hyperbolics. I have rules in my formula book for inverse hyperbolics, where they are defined in terms of logs, something we were practicing earlier in the chapter on hyperbolics. So I'm now going to apply these two, this formula here, to come up with the final solutions. So we have 1/√3 log 5/4 plus 5 squared over 4 squared plus 1 square rooted minus log 1 plus, that was a minus, the square root of 1 minus 1. Laws of logs then allows me to simplify this to 1/√3 log 2. So that's using the rules for integration of inverse hyperbolics. You may get this with a fraction that you have to split first, as we did when we were doing inverse trig. Again, a review of the examples in the textbook will assist. So that's doing integration using the rules from the textbook. If we run into problems, it's best to go to the definitions and convert from hyperbolics to expressions involving exponentials, and it may well then be possible to integrate those easily as well. So you have a further technique that can help you. Now we're going to have a look at examples 3 and 4, which ask us to use appropriate substitutions. So, example 3. This introduces using hyperbolic substitutions for solving integrations, and some of these questions are tricky. So let's work through question 3, and then it will be good to practice some of the harder questions. So, as always with these types of things, we need some pre-working. Now, the pre-working I need for this one is my substitution is going to be x equals sine of u. Now, why do I want it to be x equals sine of u? I've got a clue in the question. It's asking me to come up with that as part of my answer. And I've also got a clue here. It's 1 plus x squared in the question with a square root. If I refer to my formula book and I look for one of these in the format where we have an a squared plus an x squared with a square root, it gives me the standard result as the inverse of sine of x over a in this case. So that gives me a clue that I'm probably going to be working with hyperbolic sine. So, having identified x, I can then differentiate, I rearrange, and I also rearrange to get u because I will need that at the end of the question. I'm now ready to do my substitution. So, this becomes the square root of 1 plus hyperbolic sine squared of x, and the dx is replaced with cosh. Sorry, that's not an x, that's a u. The dx is replaced with cosh u du. I can simplify what's under the square root by use of my hyperbolic identity. So this becomes the square root of cosh u squared times by cosh u du. Simplifying further, I am left with cosh squared u du. I now have an expression that I know how to integrate. It's a double angle integration. So replacing the squared term with the double angle, we have a half cosh u 2u plus 1 du. Integrating, I obtain a half times by a half sine 2u plus c. So I've now successfully integrated. The remainder of the question is now about returning the question into a solution that contains x's, as I've been asked to show in the question. So we have, multiplying this through, we have a half u plus a quarter of, we've got sine 2u. I'm going to use the double angle here. I'm going to use 2 sine u cosh u plus c. Why have I moved to having the double angle there? Because I now no longer have a 2u, and that is going to allow me to replace these trig terms with the substitution and takes me back to x. So we have a half times u, which is a half r sine x, plus a half of sine u is x, and then I need to multiply that by cosh u, and cosh u can be written having considered the identity. So that is the square root of x squared plus 1 plus c. And there I have the required result. So I had to identify hyperbolic substitution and go through my normal pre-working. The choice of the hyperbolic substitution can be guided by the formula book or thinking through how you're going to simplify the question into a single term rather than a number of terms, which were in this case under a square root. I then arrange my substitutions, I apply whatever integration technique I need to, and then I make sure that I have put the x's back in replacement for the u's. So that's question 3. There are suitable questions in the textbook as well to see more examples. And last but not least, we have one further type of question to have a look at, and that is the sort where we have quadratic on the bottom of the fraction. If you recall from doing inverse trig integration, we completed the square. So completing the square for this quadratic, we achieve this result here. Now we've seen this result, we can start to see why they have suggested in this case that we use the substitution x minus 4 equals 6 cosh u. That substitution will allow me to write the completed the square in terms of a hyperbolic function, in this case 6 cosh u squared minus 36, which is 36 cosh squared u minus 36. Carrying on with my other pre-working, my substitution is to be differentiated, so dx by du minus 4 disappears, and we get 6 sine u here. That means that dx is 6 sine u du. Now, subbing into the question. So we've got 1 over the square root of x squared minus 8x minus 20 dx. That's going to give me an integral as 1 over. Instead of the quadratic, I'm going to replace the square root of 36 cosh squared u minus 36 times by 6 sine u du. Applying the square root and simplifying, that's going to give me 6 sine u divided by 6 square root of cosh squared u minus 1 du. Now, cosh squared u minus 1, using my identity, is the same as sine u, and it has been square rooted, so I am being asked to integrate 1 with respect to u, which gives me u plus c, which I can write out as cosh of x minus 4 over 6 plus c. I've done that in my head. I could have added it to the pre-working at the top of the page. So we could have had u equals x minus 4 over 6 cosh, that expression. Okay, so that's how to complete that question using substitution. A reminder that I could, of course, have done it directly using the results from the formula book by completing the square and writing it in a suitable format, so we could have thought of the integration as 1 over the square root of x minus 4 all squared minus 36 dx, and use the formula book. So depending on what the question asks you, asks you to use a suitable substitution, you have to work harder and do it this way. If it asks you just to integrate, you can put it in an appropriate form and use your formula book. And that is hyperbolic integration.